Hey guys, I'm Jens, CEO of WunderGraph. I'm here today with Nithin, one of our engineers working on Hub. Yeah, and today we're not intending to kill you with PowerPoint, but we want to give you a demo of what we've been building for the last couple of months, introducing Fission here, but ultimately the Hub, because we have learned from so many customers that one of the big pillars to move forward with APIs is good schema design, governance, and collaboration. And yeah, ultimately that's what we're solving with our new product, and we're exciting to share that with you today. So let's get right in. Cool. So just as a quick intro, WunderGraph does Federation now for I think around like 3 years, and we have built an entire Federation stack. You might already know, for example, Cosmo, which is the GraphQL schema registry. It's also responsible for observability. We have Cosmo Router that does all the routing between client requests and subgraphs, query planning, all that kind of stuff. Then over time, we have learned that many of our customers, they don't just have like request response patterns, but also event-driven architecture. For example, using Kafka, we have heavily invested into that ecosystem to bridge the gap between GraphQL Federation, GraphQL subscriptions, and event-driven architecture. We call this Cosmos Streams. Another area we have heavily invested in is connecting data sources to the graph that are not already GraphQL, which is quite common. The value of GraphQL is there, but one of the biggest hurdles is bringing non-GraphQL APIs to the graph. And yeah, people don't have the time and resources to migrate everything, to rewrite everything. For that, we have built Cosmo Connect. It comes in two flavors. You can run gRPC plugins as a sidecar of the router. So it's a very lightweight approach. You don't have to deploy everything. Or you can have dedicated gRPC subgraphs. They replace traditional subgraphs with the many benefits that you don't have to solve data loading anymore, and you don't have to deal with GraphQL in the backend. So we're simplifying the stack. Yeah, that is what we have built so far. Plus one new component, Hub, with a focus on collaboration, API design, and governance. That's what we show today. And yeah, that's the Federation stack. And now let's talk about the new problems we're solving. So to kick this off, two questions to consider. Question number one is, as an API consumer, do you prefer monoliths over distributed systems? And we were asking these questions in our workshop we did in Paris, API Days Paris, and the majority of participants, they were quite clear that it's easier to work with a single API to integrate from the client side against a single API versus integrating or working with a distributed system. Let's say you have a Next.js app and it talks to a single GraphQL API. That's easy, versus a Next.js app that has to talk to 20, 30, 40 different REST APIs coming from different teams. That can be quite complicated. So generally, we prefer, as an API consumer, we prefer monoliths. And then we have the second question. We also asked that in Paris. When done right, can microservices help organizations scale APIs across teams? We also asked that question. We got a very clear answer. Monoliths are generally preferred as a solution for a single team. And the moment you break up a service, or a moment you kind of split responsibility across multiple teams, you have effects of Conway's law, where people say, yeah, Conway's law, organizations ship the org chart. But really what Conway's law means is two teams don't talk to each other, and they they have to build something together, and they work in a different rhythm. So to reflect the structure of the org, it's actually simpler for them to try and have some level of isolation where one team can work on one part of the domain, the second team works on another part of the domain. And so what happens is we're splitting the services. And so what that kind of leads to is a problem, because if you think back, first question, API consumers, they prefer a monolith. But if you actually want to scale out an API or scale out APIs in general across teams, now you have the problem that you actually want to have microservices. So consumers prefer microservices. Scaling an org requires consumers prefer monoliths, and to scale an org, you want microservices, and that creates like a gap because um, people in the microservices with a service first approach, you're building in your silo and you're thinking about how to implement something in your microservices, versus if you're on the consumer side, it is not actually super clear what is the ownership of the domain. If you look at the monolithic GraphQL schema, and you might see an entity and you might have questions about that entity, then you don't even know who to talk to, because the GraphQL schema that you see, it is not reflecting the structure of the org, and you first have to dig into who is behind that, who's behind the service. So what that leads to is like a service first approach instead of a schema first approach. In a schema first approach, you would always think in the monolith and think about the use case of your user. Um, and people start building in silos, so they might be building something that's not accurately what the customer needs, and yeah, the unclear domain ownership. So we looked at this kind of problem, and we also ask our customers, how are you designing schema and APIs today? And what we have learned is very interesting. So they said, well, we create Miro boards. On the Miro board, you see this on the left, we have this box with the posts. We create screenshots, or we bring in UI mocks from Figma. And then we try to use code boxes or post-its and try to figure out what could be the API for that use case. So we're not starting in the microservice. We're not thinking about our backend or the database or any of that. We're thinking about how could the optimal API look like for that particular use case. And so here you can see we take the use case and we derive the schema. That is already quite good, but actually, instead of coming up straight away with the schema, there's even a better approach, and it's actually not even a very new one, because if you go to this blog post from Mark Lara, tech lead at Yelp from 2020, and he's still working at the company. He had this great idea of the dream query, which means instead of designing an API by creating endpoints or the schema, you just write the query you need to support the user interface. So if you go back one slide, Nithin, just for a second. So imagine here you have this posts view. Instead of creating the schema, just write the queries you need, the dream queries, and then from the dream queries, work your way towards the schema and work your way towards the microservices. And that is exactly kind of how we learned people would optimally work. And yeah, that leads to the solution that we implemented in Hub. And Nithin will show you how we came up with that and how it all works.
Yep. Thanks, Jens. So far, the current established solution is build out microservices, build out the graphs for each service, and then we compose them together. Right. But to actually go from a dream query the other way around, we have to actually flip the script. So what we did is we developed a new algorithm and we call that Fission. And like Jens mentioned from the blog post, what we would enable you to do is to first design this dream query, the query that the clients are going to consume, and that's going to drive how you're going to structure your schema for the consumer facing API, and then you're going to delegate them to individual services. So how does Fission work at a very high level? So like I told, so you take this super graph that you envision, and then you provide all the subgraph mapping. So you provide where data needs to come from, and you also provide entities, so you can jump between services, and you provide data dependencies. This can be within the same service or across different services. So you provide all this data into this algorithm, and what Fission would do is it's going to process that, and what it's going to produce are the actual subgraph schemas. So the product of this new algorithm would be the schemas for each individual service that you have. uh, so how does it work? How does it look? We can actually see it in action right now, and I'm going to show that to you. So what I'm going to do now is I'm going to jump to Hub. So Hub is the new thing that we are building, which kind of encapsulates this new algorithm, and you can interact with it. So here what we do is we provide a canvas where multiple people can come and collaborate on the schema design together. And this is how you start. So you start super simple. So you start with just the root types. In our case, we only have the query. And then depending on the use case that you have, you kind of build out the canvas as you go. So now let's say I have a use case where I need to know more about my graph. I need to know more about my user type. So what I can do is I can search over here. I can search for user. It seems like we already have a query for that, and I'm going to click on the user type. What I can do now is I can see what all the fields are there in under this entity, and the next thing I can do is I can see which subgraphs all of these are coming from. So we know we provide this very visual way to see relationships between services, which services contributing what fields and whatnot. So that's kind of how we explore the graph and we see what's in it. And the next step, let's say we have a new use case. Let's say we need to now start modifying a graph. So what I'm going to do is I'm going to create a branch out of this, similar to how you're familiar with GitHub, etc. And let's say I have a feature where I need to add a bonus. So since it's an HR platform, I want to track bonuses of all my employees. So I'm going to create a branch called bonus just for that. So once we have the branch ready, what I'm going to do is I'm going to reset the canvas. So, we start from scratch. So what I'll do is going to create a UI mockup. So a UI mockup is basically what you do with Figma or whatever design tools your organization uses, and you bring the UI mockup over here. So I already have a UI mockup, which I'm going to bring onto the canvas. All right. So now that I have the UI mockup, what I can do is I can select the portion of the UI for what I'm going to be building. So I'm going to select this table right here. And the moment I do that, it brings up this operation builder. This operation builder is the dream query that we talked about before. So what we are going to do now is going to construct this query and see if our graph meets the needs of the client. So we can see that we need a table with the full name, phone number, compensation, and the bonus. We already have the user's query. We can make use of that. We'll grab the ID of the user, the full name, the total compensation, and we can see that we are actually missing a particular field, which is the bonus field. And we can quickly create that right here. So I'm going to click on the create button, and it's going to bring up the creator. I'm going to type in bonus, and let's say this is float, and I'm going to hit create. So now you can see that bonus has been created on the query, and I'm going to sync this to the canvas. The moment I do that, you can see now we have placed things that we care about. And now let's say I'm a front-end engineer. I don't really know where this data needs to come from, or my knowledge about the graph isn't that well versed. So whom can I approach? So what I can do is I can hover over this, and what do I know? So it's Jens after all. So Jens, can you help me out here?
I absolutely can help you. Um, I just want to move one step back because you were like quite fast in showing that. And I want to emphasize on one thing. So we had a query, and we had some existing fields on our schema, and one thing was missing. And the typical workflow when something is missing on a query is you would somehow need to go to a schema, and you would need to add that bonus field to a schema. It's impossible for you to query something that doesn't exist. There's no tooling to do that. The problem in Federation, and this is what I try to get at with the two questions, the problem in Federation is you can't just add a field to the monolith because it is not a monolith, it is a supergraph. How do I get a field into a supergraph? I need to add it to a subgraph and run composition. But the problem is, and you see that here, we have a front end dev, Nithin. He wants to implement a feature, and he's not even aware of subgraphs. And he's also not a backend developer. It is not his responsibility to think about composition and how to field and how to add a field and whatnot. So the resulting situation is, and we see that in a lot of our customers, is Nithin would now go to a platform engineer and ask, hey, I have this user entity. I need to change some fields there or add a field. Who do I talk to? And at that moment, the workflow stops. And we really wanted to build a workflow that continues going. And the first part is, um, we don't want to replace the platform engineer. We want to free them up from telling people who owns what. Because yeah, a human shouldn't do the job that a computer can do. We can easily track who owns what. So we have a concept in Hub of entity ownership, which is our governance concept. So here you can see you can have graph admins. These are the guys who have the superpowers. Then you have owners for different types, and you have owners for subgraphs. We make that distinction because um, it is possible that someone like an architect is responsible for yeah, enforcing good governance and schema quality for an entity, but they might not be owning a subgraph. And ultimately, the subgraph or microservice owners, they should have the last call that they take on some responsibility. Okay, so coming back to our scenario here, Nithin needs that field. He can see through governance that I'm an owner. And the one thing he could now even do is just create a thread, because maybe I'm not even here in the room, but he could create a thread and he could write me a message because he knows I'm an owner and say, hey, can you assist me? So that we can work synchronously here, like we're currently doing, but we can also start an asynchronous discussion and say, hey, I have this task here. I need that bonus field. What can we do? Okay. So the next step for me would be, let's say I'm the architect. I want to fully understand the behind the scenes of the user entity. So Nathan, can you show me all the fields of that entity?
Yep.
Okay. And then please navigate to all subgraphs so that we see which subgraph owns what.
There you go.
Okay. And then what subgraphs do we have? We have at the top, we have HR. Okay. We have payroll.
And we have users.
Okay. Can you click on the arrow or the connection of payroll?
Yep.
Okay. You can see on the right side, if you zoom a bit in, we have a salary, total compensation, and benefits coming from that subgraph. And this is kind of like giving you a hint what fields are coming from that service so that you can visually really understand this is the responsibility. And yeah, in our case, me as the architect, I believe that subgraph is the right place to put this logic. So what we can now do is we click on the bonus field on this red thing, and we assign it to the payroll service. Okay, you can see it's now added here. The red alert at the bottom that we have unassigned fields, it is gone. And yeah, now everything is resolved. And you can see from a workflow, we have a new use case. We add the dream query, we assign the fields, and now we are we done, Nathan, or what is the next step?
Yeah, that's pretty much covers how you kind of make changes on the super graph and how you can delegate to services, and you can kind of have a look at the schemas over here as well. And what we can do next is create a proposal, to see all the changes that we have made, and we can also see who the reviewers are, and we all can also see what protections we have in place whenever you make changes to your schema. And here in this case, you can see that we have schema checks established. It checks against actual client traffic to see if you're going to break anything. And at the bottom, you also see that each item, like, or each element in your graph, like subgraph types, have owners, and those owners are automatically added as reviewers. And you get into this entire approval process, and only then can you publish your graph and go forward. So that's going to be the next steps once you finish modifying your graph. So having that covered, there's another way you can do this. So what I'm going to do is I'm going to undo the changes that we have made, and this is going to highlight the magic of Fission. So let's say I want to create a new service altogether, because bonus is something that's going to require a lot of computation. Right. So what I can do is I'm going to do the exact same thing. I'm going to click on this button, and instead of assigning it to existing subgraphs, I'm going to create a new subgraph out of this. So I'm going to call this the bonus service, and I'm going to hit create. So one thing we have to notice here is that the user entity is automatically imported along with the key. And in our case, key is the ID. And if we go to the schemas over here, we can see that a new subgraph is created. And what Fission understands is that, hey, to compose this service along with the others correctly, and for the query planner to make a jump to this microservice, we need to create convert this user into an entity. And since the entity already has a key call ID, we need to bring that into the subgraph as well. So this is what we were talking, that what Fission does. It kind of removes the complexities of understanding federation altogether, and does the job for you, and ensures that your graphs are always composable. So that's it for the demo. Let's go back. And yeah, so what are the payoffs? So what this gives you is the best of both worlds. So you can think in terms of micro monoliths, and you still build microservices. And this is a use case driven approach. You think about the bigger picture, and you remove silo development, so people come onto the same place and collaborate and stuff. And lastly, it opens up API design to everyone. So like I showed, it removes the complexity of federation. It takes the learning curve out, and so people who are not well versed with federation, and ones who are not developers, can also contribute to the design of your supergraph. And yeah, so we've reached the end of our show here. So if you want to try out Hub, it's right now open for registration. You can get in, try it out very quickly. Or if you need a one-to-one walkthrough, you can book a call with Ethan. And yeah, Jens, anything else?
No. Um, Thanks for watching. We're extremely exciting because we believe that is the next step in making the graph more accessible and allowing more people to contribute to the graph, ensuring a high quality schema. If you're looking forward, the next wave of applications, it is not going to be just web apps or iOS, Android mobile apps. The next wave that's coming is AI applications, LLMs or agents. And the most important bit for agents is that they can access the schema, and they need to access all our data from all services. Federation is amazing at orchestrating access to all our service, but what's most important is that we stay on top of our schema. We stay on top of the graph. We have a high quality schema. We have good descriptions and good field naming and everything, because otherwise LLMs can't make sense of your schema. So for us, the next step is to enable those future use cases, is to help organizations to collaborate and govern on good schema design. And yeah, that's what we're doing here as a next step. So thanks again for watching, and yeah, check out wundergraph.com/hub, or like Nithin said, if you want to have a one-on-one demo and a walkthrough, then reach out to Ethan. Thanks you.